Welcome to this lecture on process control, the chapter on Laplace transform. So here we are going to find the inverse Laplace transform of some functions. In the previous two lectures, I have found the inverse of 4 functions. This is the 5th one. These functions and their inverse will be very useful in the study of process dynamics. So let us see what is this function. This function for which we are going to find inverse Laplace is this f of s equal to 1 by s into tau 1 s plus 1 into tau 2 s plus 1. So we will find the inverse by the partial fraction method. So let us split this into partial fraction. So there will be 3 terms, there will be 3 constants. So we'll split into 3 terms and evaluate the 3 constants a, b and c. So we'll split this into 3 terms, a by s plus b by tau 1 s plus 1 plus c by tau 2 s plus 1. If you multiply throughout by the LCM, you get this. Left hand, this side is 1 and a into the other 2 plus b into s into this plus c s into tau 1 s plus 1. Now let us evaluate the 3 constants. A, B, C. So first easier thing is, so let us substitute s equal to 0. When you substitute s equal to 0, you're going to get 1 equal to, here tau 1 s becomes 0, tau 2 s becomes 0, so 1 equal to a. And here s equal to 0 means this becomes 0, this term. And similarly cs, this term also becomes 0. So you get one answer, a equal to 1. Okay. So next, so let us substitute. What do we do? So let us substitute s equal to 1 by tau 1 let us substitute s equal to minus 1 by tau 1. So when you do this, since s equal to minus 1 by tau 1, it means tau 1 s plus 1 will be equal to 0, right? So wherever there is tau 1 s plus 1 will become 0. So what are we going to get? 1 equal to, so this is 0, first term is 0, second term is b into minus 1 by tau 1 into minus tau 2 by tau 1 plus 1, and this term cs term is going to be 0. This is here, this will be 0. Okay, this will be 0. So if you simplify this, so this is equal to minus b into tau 1 minus tau 2 by tau 1 square. So which means b equal to minus tau 1 square by tau 1 minus tau 2. Okay, so we got b answer here. So already you got a is 1 and b is this. Okay, so next let us substitute s equal to minus 1 by tau 2. So here tau 2 s plus 1 will become 0. So if you substitute this, b terms become 0 B2 term, B term becomes 0, tau 2 s plus 1. Wherever there is tau 2 s plus 1, that term becomes 0. A term also becomes 0. So you are left with only C. So this is going to be 1 equal to A term is 0, B term is 0, C into minus 1 by tau 2 into minus tau 1 by tau 2 plus 1, that is equal to that is equal to 1 equal to C or minus C into tau 2 minus tau 1 by tau 2 square, or C equal to minus tau 2 square by tau 2 minus tau 1. Okay. So we get C equal to minus tau 2 square by tau 2 minus tau 1. Already we got B here. So this is B is minus tau 1 square by tau 1 minus tau 2. So to make it similar to this tau 2 minus tau 1, B also, let me write B as plus tau 1 square by tau 2 minus tau 1, so that the denominator is same for both B and A. So I written B as the minus sign I interchange here, so plus tau 1 square by tau 2 minus tau 1. Now let us substitute A, B, C. A is 1, B is this, C is this. So let me substitute A, B, C into the function. So I have substituted A, this is A by S. For B and C, tau 2 minus tau 1 is common. So I written 1 by tau 2 minus tau 1 and tau 1 square. B is numerator is tau 1 square by tau 1 s plus 1. C is numerator minus tau 2 square, so minus tau 2 square by denominator tau 2 s plus 1. Now we have to find the inverse of this, inverse Laplace of this. Take inverse Laplace. Let me rearrange this 1 by s as such, 1 by tau 2, because it will be easier to, rearrange in such a way, it will be easier to take inverse Laplace. So this numerator and denominator will divide by tau 1. So this becomes tau 1, denominator becomes s plus 1 by tau 1. Similarly here, divide numerator and denominator by tau 2. So numerator is tau 2, denominator is s plus 1 by tau 2. The idea is this becomes 1 by s plus a form. Both the terms in the bracket becomes 1 by s plus a form. 1 by s plus a inverse is e power minus at. So that's the formula I'm going to use. So it becomes easy. Now take inverse f of t equal to first term 1 by s. Inverse is 1 by inverse of 1 by s is simply 1 minus or plus 1 by tau 2 by s tau 1. And here the first term, tau 1 is a constant, 1 by s plus a form. So it is going to be tau 1 e power minus at. A is 1 by tau 1 here. So e power minus t by tau 1. So this is the inverse of the first term. Second term is similar. This is also 1 by s plus a form. Tau 2 is a constant. tau 2 into e power minus t by tau 2. So this is the inverse of the given function. I have just rearranged this in this form. You can also write in this form here 1 plus 1 by tau 2 minus tau 1, or 1 minus 1 by tau 1 minus tau 2. I interchange the sign, put minus here, and this tau 1 minus tau 2. Just all same. Tau 1 e power minus t by tau 1 minus tau 2 e power minus t by tau 2. So same thing I written typed here, the print form, same. 1 minus 1 by tau 1 minus tau 2 into tau 1 e power exponential or e power minus t by tau 1 minus tau 2 exponential t by tau 2 exponential. So this is the inverse of this function, given function. So as I said, this inverse of this function will be very useful when you study the dynamics of some processes for some particular input. Fine. I hope you understood this. We will come up with more functions for which you will find the inverse Laplace transform in the next lectures. See you till then.